Hey guys, what's up? Welcome back to the Python Fundamentals series. Today we are going to talk about data types. So data types in Python are a bit easier to handle than in other programming languages, I feel. And to give you guys an overview, I want to start with Geeks for Geeks and their article about data types in Python. So as you can see here, they separate the data types into like 5 broader categories, which is numeric data types, dictionaries, booleans, sets, and sequence types. And they split these up in, well, the major portions in numeric data types are integers, floats, and complex numbers. Dictionaries, booleans, and sets are what they are, and sequence types are strings, tuples, and lists. However, depending on the source, they sort of tend to list them differently. So, for example, I found this article by Mr. Patil. I'm not even going to try to pronounce his first name because I'm going to butcher it for sure. And he separates them into like 7, if I'm counting correctly, different categories. And he has these subsets of sequence types as their own sort of category. So he has strings, lists, tuples, dictionary sets, booleans, and irregular numbers as their own data types in Python. One quick thing to note up front is that lists, which I'm going to talk about later more, are what's called mutable. That means you can change the order of the arrangement of elements. That is not the case for tuples. In tuples, they stay fixed. So if you pass in a tuple, for example, it's very important that you have the numbers in the order they're supposed to be. And sets are another interesting data type in Python because they only allow unique elements. That means elements that are replicated a number of times will just be cut out of the set. Okay, so let's start. So I have here Visual Studio Code, and I have my Python 3.7 Anaconda interpreter directed to the IDE. If you guys want to know how to set up the IDE for Visual Studio Code, you can check out my first video from the Python Fundamentals series. So one neat thing in Python is you can just declare a variable like this. For numeric data types, it's as easy as writing a equals 1. And to prove to you guys that this works, let me print this out. I'm using the shortcut in Visual Studio Code, which is Control F5, and sure enough it runs and it prints out 1, which we are expecting because we assigned 1 to A. We can also assign any random integer to it, run that again, and voila, it's still the same number. So as I said before, there are different numeric data types, and I guess the first category would be integers. If you guys come from a different programming language, you are probably used to casting variables in a different way. I think in C++ it would be something like, what would that be? I think 32. And then you say, from the standard library, pick the data type unsigned integer A, and then you assign a value. And in C++, you also have to keep the semicolon in the end, so the interpreter knows that the line ends. In Python, we can spare all that, and the new line also tells the interpreter that it's done. So it's, I think, fairly straightforward and very with very few syntax, so it's very easy to write, I think. So if you, in general, like, let's start off with that. I think that is important, especially for numeric data types, before we continue. If you have a variable, say if you run a piece of code that you haven't written or you're not sure what is assigned to a variable, you can always check the kind of data type that you're interested about by using the type function. The type function returns usually a class, so the object of the data type. And you can see that here, if I run that, it gives you class int, and that stands for integer. Fair enough. And the reason for that is that Python, for every variable, assigns an object, or it creates an object, and this object has its own unique properties which come in handy, and I'm going to talk about in later tutorials about some of the functionality that comes with that. Okay, so we have talked about integers now, but there's obviously different numerical data types also, and I think the most important one are floating point numbers or short floats. And in Python, you tell the interpreter that you are dealing with floating point numbers when you lose the dot notation. So if I go 2.0 and let's assign that again to a variable, let's say again a is 2.0, and we want to know what a is, and we would also want to know what the type of a is. We can do it like this and run that. And you can see it returns 2.0, and the class of a, of the variable a, is a float, that is a floating point number. Now something that is different again to other programming languages like C is you don't have to say how big the number is supposed to be. I think by default Python casts a float 32, so in C++ there would be something like this. Let me just make a new line here to show you this. I think this is how you would do it in C++, which is an overkill because you don't need that kind of precision. So you wouldn't need 32 bits. I think float 16 would do the job as well. But yeah, I think this is how Python default casts floating point numbers. I'm not sure about that. I have to look this up. Okay, so floating point numbers are fairly commonly used. It's scientific notation, and yeah, basically you guys won't get around using floating point numbers ever. Something interesting is if you have, say, two integers. So let's say a is 1 and b is, or let's do something more interesting. Let's do 9 and 2. And we would want to first know what the types of these two variables are. So let's print them in one line actually, because I'm lazy. And then we do something interesting, which is we provide the result of the division of these two. So I'm not going to reassign it. I'm just going to print the type that is returned by Python when you divide. Oh, I should divide a by b, not 9 by 2, because then it's pointless to assign them in the first place. All right, so let's run that. Sure enough, I have a syntax error because I forgot the parentheses. Okay, so it ran, and turns out a is an integer, b is an integer as well. However, the result of the division is a floating point number, because the result of the division is not cannot be represented as an integer. So what you end up with is 4.5, obviously, which is not an integer anymore. If we do something like a integer division, so 8 is obviously divisible by 2 without a reminder, so the result should be 4 if my math is not off. And if we run that, we still get 4.0. So that gives you an interesting lesson or an overview of how Python functions with different operators. So for the division, it always returns a floating point number, even if you divide two integers. That is something you have to keep in mind if you use operations or operators like the division, which is just this /. Alright, so I think the last interesting numeric data type is a complex type. Let me capitalize that so to keep the consistency. And I guess some of you guys have stumbled upon complex numbers if you had courses in further mathematics or engineering, signal processing, anything like that, physics, where you stumble across complex numbers. And so in math, a complex number is defined as the real part of a number plus the imaginary part of a number. And you can think of it as a plane of numbers where the x-axis is real numbers, and orthogonal to it you have the imaginary axis with the complex numbers. And you could describe any point in the plane of these complex numbers with this notation, with both of these portions, the real and the imaginary part. So the way you denote a complex number in Python is pretty straightforward. You just let's do the imaginary part first. So if you have only the imaginary part, say a is 3j. Now this looks odd. if you're not used to it, but let's see if this actually exists. So if we want to print it, sure enough it runs, so there's no syntax error. And if we would want to double check if we are actually dealing with complex numbers right now, we should print out the type. And sure enough, A is a complex number. You could also add the real part, so in this case it is silently already knowing, or it sort of deals with the real part as being 0, so like this. And if you, oh sorry, I wanted to print out the number. So it's like this. And again, it gives us 4j, so it left out the 0 part, so it's a redundant information, so you can leave it out in the first place. However, if the real part is non-zero, say it's 2, like this, and you print it out, sure enough, the real part then is non-zero. And it also puts these nice parentheses around it, so you know that is one complex number. Okay, so that's basically it about the numeric data types. And yeah, I hope to see you guys in the next video to explain to you dictionaries. Peace.